Good morning and good afternoon, everyone. Welcome to Data Physics Coffee Break Seminar Series. My name is Holden Gibler. I'm an Applications Engineer for Data Physics. Today we'll be going over the Compare Signals feature in SignalCalc 900. Today is May 15th, 2023. We're going to jump right in. So here we have our managed test screen, which I hope you all are familiar with. To access our Compare Signals feature, it's going to be in the graph attributes of a test. We can either make a new test, which is going to be up here, or we can edit an existing test, which I'm going to do for the sake of this demonstration. In order to do that, I'll right-click, go to Edit Test Setup. Here we have our Test tab, our Channels tab. Everything looks great here. Here's our auto power spectrum measurement. And I just have I have a input channel trigger, and I have an Excel mounted to my desk. And when I tap it, I'll get a reading. But I need a signal to compare to use our Compare Signals feature. In order to do that, I can add a user signal. So I'll go over a little bit on our user signals here. I'll go ahead and click Add Group. I'll go to User Signals, and I can import a signal from either a run, a save, a test file, or an ASCII file. In this case, I'm going to import an ASCII file, and I'm going to import this ASCII file that I have open here. I just have frequency on the left-hand column, and then my magnitude in G's on my right-hand column. And I want to import this because this is my limit or my comparison that I want to compare my new results to and see if they pass or fail. So what I'll do is I will click here. I'll click Compare Signals Demo, hit Open. And then here is our ASCII import table. In this case, this was a frequency domain file. So I want to select frequency. It is a linear spectrum, so I'll select linear. My data formats and magnitude, standard data scaling. Here's where I'll define my columns here. So my frequency column is going to be column 1, as seen in this column 1. And then my magnitude in G's is going to be column 2. So then I'll select column 2, and it's going to be in G's. So I'll type G's. And this is just a brief overview into our user signals import. We'll probably do a dedicated video in a future date, but in this case, we just need to go over this to use our Compare Signals feature. So again, I'll go ahead and hit Create. And then I can see my demo signal up here. So I can get a preview of what it looks like to make sure I selected all my scalings correctly. I'm going to give it a name. I'm going to call it comparison. And then I'll call it add signal, and I'll give it name again. I'll hit OK. And then I'm going to hit close. So here we have now in my user signals here, I have my time history. I'm saving all these different types of signal types. And now I have this new signal, which is called comparison, which will display on the graph. Okay, everything looks good. We're going to go ahead and hit save. And then I'm going to take a measurement. So in order to do this, I have my 901 connected. I'll hit initialize. I'll hit continue. Press start. And then I will tap my desk. Okay, we have time domain data. We'll look at our frequency domain plot. Here is our frequency domain data. What I want to do now is I want to add my new user signal and then compare this new response to it. So I'm going to right click. I'm going to click Add Signals. And then I'm going to add this new comparison signal. This is where you can change the color or the style. Again, if anything like this interests you, you can look at our YouTube channel and go to our graph attributes coffee break webinar to give more detail on some more things you can do with graphs. Click OK. So now I'm overlaying my new data with my old data. And now I want to access the Compare Signals feature. So I'll right click. I'll go to Graph Attributes. Then I'll have the Compare Signals tab open, and then it'll be the rightmost tab. And here we have the option to enable Compare Signals. We also have comparison type. If I check Compare Signals, nothing's going to happen because I haven't defined my comparison type. So for each signal displayed on the graph, you'll have to define a comparison type. We have measure, upper limit, lower limit, or none. Rule of thumb is your newer measurement that you want to compare to will be measure, and then your old comparison signal that you either import or review from a different run will be upper or lower limit. In this case, I'll define it as a lower limit. And then here's where I can check for my pass or fail criteria. We can see if it passed or failed based on this allowed exceeding limits here. If I just check pass, looks like it passes. If I check fail, it won't print a fail. We'll explain the parameters here. So the max allowed lines exceeding limits. These are the max amount of frequency lines that can go over or under your defined limit. So in this case, any frequency line, if there's less than 20 of them that are underneath my lower limit, then I'll print a pass. But if, say, I crank this down, maybe let's do 5, and then hit apply, we'll print a fail. So this is how I can determine how how tight my pass or fail criteria is. And if I want to display the number of lines outside of my limits, I could check this. It looks like there's 12. I could also view it as a percentage. And I can look at my mean exceedance and my max exceedance as well. And I can change the format of this as well. Right now I'm using my axis format, but I can go to user, and I can put in decimal, and I can see the mean and max exceedances as well. All right. So then I will crank this up a little bit, and we'll take a few more measurements. And then I can also annotate this, or I can edit this annotation. I can make it transparent. I can change the color. I can also disable the border, so it just prints text. And I can drag this somewhere. Maybe you want to view it that way. I'm going to go ahead and take another measurement. So I'm going to tap my desk again. Do another pass. And we got a fail. So my fail here displays the number of lines outside of my limits, the percentage of lines outside the limit, so 2.87%, and my mean and max exceedances. And if I wanted to say, okay, maybe I'm okay with 3% of my frequency lines being outside of my tolerance, then I can right click, I can go to my graph attributes, and I can edit this. It's like at 30, and then we'll pass. So it's a good way to do on the fly measurements and see if you want to accept data or not. Okay, I'm going to go ahead and stop this measurement. And then this is also available in a review mode as well. So if I hit yes in my review, I can edit this all in my review mode as well. Thank you.
Again, my name is Holden Gibler, applications engineer for data physics. My contact info is down in the bottom if you have any questions. For more information, you can visit our website, dataphysics.com, and I hope you all have a great rest of your day. Thank you.